Hello students, welcome back to another video of MATHIPHY. In today's video, we will do paper 6 of course code 0625 from month May-June 2025, variant 1. Question number 1 says, a student determines the density of a ball. Part A says he places the ball between two wooden blocks as shown in figure 1.1. So here's the ball between two wooden blocks. He takes two measurements D1 and D2. On figure 1.1, measure the length D1 and D2. So I'll place the scale over D1 first and align it with the dotted lines perfectly. So this length is roughly 2.7 centimeters. So I'll write it over here. And the D1 length, I'll again align my scale with the dotted lines, and this length is nearly 2.5 centimeter. Second part says, using your measurements, calculate the diameter D of the ball, show your working. We have got two values of the diameter 2.7 and 2.5, and to measure the D accurately we'll take average of both values. So to take the average, I'll add 2.7 and 2.5 and divide it by the number of values. We have two values right now, so I'll divide it by 2, and the average value for the diameter will turn out to be 2.6 centimeter. Third part says, explain why this method is used to measure the diameter of the ball. We are using this wooden block methods because if we directly try to measure the diameter of the ball like this, ball is a spherical shape, and when you put a scale and try to measure the diameter, there are much chances that we are going to end up with a parallax error. So the method that we have used right now, the wooden blocks, is a good method because measuring diameter by this method avoid the parallax error, and with scale it is hard to measure the diameter. B part says calculate the volume V of the ball by using this equation and include the units. So we are provided with the equation of volume V is equal to 0.52 times d cube. Now we have the value of d, which is the diameter. We have just calculated the average, it is 2.6. So I'll put that into this equation. It would be 0.52 times 2.6 cube. Solving this into your calculator, you will get the volume as 9.13952, and the question has given us the values in two decimal places, so I'll also write the decimal to two decimal place only, and the answer would be 9.14, and the units for volume would be centimeter cube. C part says the student measures the mass MD of a dish, which is 102.5. He places the ball in the dish and measures the combined mass MC of the dish and the ball. 1.2 shows dish and ball on a balance. Record the reading shown on the balance. So on a balance, we have the ball and the dish both, and the combined weight of dish and ball both, which is represented by MC, is 114.1. But the mass of this dish is 102.5 grams. We have to show the readings on the balance. So the balance is reading 114.1 grams. Next part says calculate the mass MB of the ball and show your working. Question has provided us the combined mass, the mass of the dish, and we need to calculate the mass of the ball. To get the mass of the ball, which is MB, we can subtract MC, which is the combined mass, from the mass of the dish, which is MD. Let me put the values in this equation. MC is 114.1 and MD is 102.5. By subtracting these two values, we'll get the mass of the ball, which would be 11.6 grams. D part says calculate the density of the ball using the equation. This is the equation that we have. Give your answer to suitable numbers of significant figures for this experiment. Include the units. We have the formula for the density. Let me put the values over here. Mass of the ball is 11.6. We have just calculated it. Divided by the volume of the ball. We have already calculated the volume, which is 9.14. So I'll plug in over here. Dividing both values, we'll get the answer as 1.26914. Now question is asked to give the values to suitable significant figures, and the values over here have three significant figures. So I'll also write my answer to three significant figures, and it would be 1.27, and the units would be gram per centimeter cube. Question number 2 says a student investigates the cooling of hot water in beaker. The apparatus is shown in figure 2.1. Here we have beaker, this is thermometer, and these two things are placed on a bench. A part says the student uses the thermometer to measure the room temperature. Room temperature is 22 degrees centigrade. On figure 2.2, show clearly the reading of room temperature. The reading is 22, so it would be 2 points ahead of 20. And this is the reading of thermometer, 22 degrees Celsius. B part says the student pours 100 centimeter cube of hot water into empty beaker. She records the temperature theta of the hot water in the volume 100 centimeter cube row of the table 2.1 as shown. So this girl took a empty beaker and poured 100 centimeter cube of hot water into that beaker, and she recorded the temperature of this hot water, which turned out to be 87 degrees Celsius, and this is also mentioned in the table that is drawn by the girl. For 100 centimeter cube the temperature is 87. Without delay, she pours 20 centimeter cube of cold water into the beaker. She stirs the water and measures the temperature of the mixture of hot water and cold water. She repeats the procedure until she has added total 100 centimeter cube of cold water to the beaker. After it, the girl will pour 20 centimeter cube of cold water into this hot water. She will stir both the waters very well and then record the temperature again. Now for this 120 centimeter cube of the mixture, the temperature will drop to 73. After it, she will again pour 20 centimeter cube of cold water and again record the drop in the temperature, and she will do it multiple times until she has added 100 centimeter cube of cold water. This is the table of values she has recorded. C part says plot a graph of temperature theta on y-axis against the total volume of water V on x-axis. You do not need to start from origin. Draw the best fit curve. So we have to draw this table on the graph that is shown. On y-axis side, we are going to take temperature in degrees Celsius, and on x-axis of the graph, we are going to take volume in centimeter cube. This is the scale that I have chosen, and it is best for the values that are given in the table. On y-axis, one small box is representing 1 degree Celsius, and on x-axis, one small box is representing 10 centimeter cube of volume. Now I have plotted all the values that are given in the graph, and this is the best fit curve that I have got after matching all the values. D part says in this experiment, the student aims to investigate the effect on temperature of the hot water as cold water is added. Part 1 says complete the sentence to explain why it is important to avoid the cold water without delay at each stage. because if you will delay the process of adding cold water and measuring the temperature, the heat would be lost in the environment and the values you will get will not be the accurate values. So the cold water is added without delay to avoid the loss of heat into the environment that can lead to false readings. Second part says complete the sentence to explain the reason for stirring the water at each stage. The student stirred the water before recording the temperature because he wants to ensure that the cold water spread evenly and the temperature recorded is constant. E part says suggest two ways to minimize the loss of thermal energy from the beaker during the experiment. From a beaker, heat can be lost by the surface of the water, and heat can also be lost by the edges of the beaker by conduction and convection. To avoid this loss of thermal energy, we can cover beaker with a lid, or we can cover the beaker with some form of insulating material. F part says name the apparatus that the student used to measure the volume of water. Volume of water can be measured by using measuring cylinder. Question number 3 says a student investigates reflection in plane mirror. A ray trace sheet is shown in figure 3.1. So this is the tracing sheet on which we are going to work. A part of the question says draw a normal to the line MR that passes through the center of MR and label the normal as NL. Firstly, we'll see what is the center of the line MR. For this, I'll grab my scale, put it on the line MR. This line is 10 centimeter long. That means the center is 5 centimeter. After it, I will pick up my protector, place it on the point that I have marked, and align it perfectly with the line MR and draw a 90-degree line. This line will represent the normal, and I will label this normal as NL. Next part says label the point at which NL crosses the line MR with a letter B. Now I will label the point where NL cuts MR with a letter B. Next part says draw a line of 10 centimeter long from B at angle of incident 40 degree to the normal below MR and to left of the normal. Label the end of this line as A. Below the line MR and to the left side of the normal means over here. So I'll pick up my protector, align it with the line MR and the normal. I can also use scale so that I can measure that my line is 10 centimeter long. And I will draw incident ray 10 centimeter long at angle of incidence 40 degree with the normal. So this angle is 40 degree. And this ray is incident ray, and the end of this ray will be named as letter A. B part says the student places the reflecting face of mirror vertically on the line MR. On the line MR, the student is going to place a mirror like this. He places two pins P1 and P2 on line AB. Mark the positions of P1, P2 with a cross on line AB at suitable distance apart. For this type of ray trace experiment, label the position P1 and P2. So if you are going to place pins, the pins should be minimum 5 centimeter apart. Now we have to place two pins P1 and P2 on line AB. So I am placing the first pin P1 over here and the next pin P2 over here, and the distance is more than 5 centimeter. C part says the student views the image of P1 and P2 from the direction indicated by the eye in figure 3.1. he places two pins P3 and P4 so that P3 and P4 and P2 and P1 all appear exactly behind each other. The position of P3 and P4 are shown in figure 3.1. Draw a line through P3 and P4. Continue the line until it meets MR. So I am drawing a line through P4 and P3 until it reaches the line MR like this. Second part says measure the acute angle alpha between this line and the horizontal line MR. An acute angle is angle that is less than 90. So question is asking us to measure the angle between MR and the line joining P3 and P4. So if I'll align my protector and start measuring the angle, it would be 10, 20, 30, 40 and 48 degree of angle. So the angle between MR and the line joining P3 and P4 is 48 degree. Although I've got answer of 48, but your answer can reach from the value 46 to 50 degree. There is nothing wrong in it. D part says the student turns the mirror through the angle 180 degree. So the student is going to turn the mirror round until the angle is 180 degree, and this is the new position of the mirror. Then the question says he draws a new incident ray at angle of incidence 50 degree to the normal above MR and to left of the normal. He labels the end of this line as letter C. This line is not shown on figure 3.1. You may draw the line on the figure 3.1. According to question, above the line MR to left side means over this side, and the ray having 50 degree with the normal would be over here. So this is the incident ray with angle of incidence 50 degree with the normal, and I am labeling the end point of this line as letter C. After it, he places two pins on the line CB and views the image of two pins from near the top right hand corner of the ray trace sheet. On figure 3.1, draw a reflected ray 10 cm long from B with angle of reflection beta equal to angle of incidence. Label the end of the line as D. I am placing the first pin P5 over here and the other pin more than 5 cm away, let's suppose over here. So this is P6. Now he is going to view the pins from this position, and he will align two other pins such as P5 and P6, and the other two pins are right in front of each other. Now question is asking us to draw the reflected ray of ray CB and make sure that the angle of incidence is equal to angle of reflection. So I will reflect the ray at 50 degree, and I will make sure that I draw a length of 10 centimeter. So here is my reflected ray at angle of reflection 50, because I know the rule angle of incidence is equals to angle of reflection, and the question is asking this angle as letter beta and this 48 angle as letter alpha. E part says suggest a relationship between alpha and beta angle. Justify your answer by reference to the results. I have calculated the alpha angle that was 48 degree and the beta angle is 50 degree. Now if I compare the percentage difference, the formula for percentage difference is maximum value minus minimum value divided by maximum value multiplying by 100. So according to this formula, the maximum value is 50 minus 48 over 50 multiplying by 100. and the percentage difference turned out to be 4%. That is very much less than 10%. That means that these two values are equal to each other and lie within the experimental accuracy. So I am stating that alpha and beta are equal because percentage difference between them lie within the experimental accuracy. F part says state two techniques that you use in this type of experiment to obtain accurate ray trace. I have stated multiple reasons: draw sharp lines, use thin pins, view the pins from their bases, and the distance between the pins should be more than 5 centimeter. You can write any two from these. Now question number 4, I'm not going to read it, but I'll just simply state that in this experiment we are going to compare the diameters of the wire with the resistance of the wire. Firstly, we are going to draw a circuit diagram. A circuit diagram will look like this. Here we have voltmeter connected in parallel, ammeter connected in series. Along with it we have a battery and a wire we are going to switch with multiple diameters. The emitter is going to measure the current that is going to supply to the wire. This wire is going to be switched with wires of different diameter, but make sure that the material and length is same. And this voltmeter is going to measure the voltage across this wire. Now in investigation, we are firstly going to set apparatus that is shown in the diagram above. After it, we will take wires with different diameters and note the respective value of voltage and current. After this step, we will measure the resistance value for each diameter using the equation R is equals to voltage divided by current. Now the question is asking for constant variables. So in this experiment, we are going to keep the length of the wire and material of the wire constant. Now coming to the table, we will draw 4 columns in our table. First is for the diameter that we are going to change constantly. Then we'll measure the voltage and current across each diameter and measure the resistance by using the equation. Last thing is conclusion. To conclude the experiment, we will draw the graph of diameter and resistance and we will study the relation between them. Thanks for watching the video. If it was helpful, please hit the like button and subscribe my channel.